we are going to, you know how we started this unit by graphing every single exponential function and then doing all the transformations with the exponential functions. A review of chapter 3. You also have to know how to graph every single log graph. And you will have to do all your transformations with every single log graph as well. Just like exponential graphs, log graphs are fairly easy. In fact, I want you to be able to instantaneously go to this log graph. All log graphs have a vertical asymptote at x equals 0. Every single log graph has the point 1, 0. Just like every exponential graph has 0, 1. Because this is a log base 4, a log base 4 graph will have the point 4, 1. A log base 3 will have 3, 1. A log base 7 graph would have 7, 1. And all log graphs have this shape. It'll go towards the asymptote and through your 2 points. Now, why does every log graph have this? Well, you already learned every exponential graph. If this is log base 4 of x, y equals log base 4 of x, that's going to be the inverse of y equals 4 to the x. So let's review how you graph y equals 4 to the x. Every exponential graph had a horizontal asymptote at y equals 0. Every exponential graph went through the point 0, 1. And every exponential graph, when you plug in 1 for x, this point changes. But because the base is 4, you'd have 1, 4. And the shape would go like this. Do you see that these two are inverses of each other? That if you know 4 to the x, you know log base 4 of x. But I want you to be at the point where you know your basic log graph instantaneously. I don't want you every time, like, hey, can you draw log base 7 of x? I don't want you to first have to draw 7 to the x and then draw the log. I want you to be able to draw the log graph right away. But if you look at about how do inverses work, you switch x and y. Do you see that it even works with the asymptote? Like if I have the asymptote y equals 0 and I switch my y's to x's, I get x equals 0. And all of our points, just the x and the y coordinates got switched. So now to answer these questions. Identify the intercepts. We just have an x-intercept. At 1, 0. Do we have any asymptotes? We have the asymptote at x equals 0. Domain and range. Well, now my domain, the x values are bigger than 0, and my range is everything. I'll get you to circle questions 10 and 11. But I'm also going to introduce you to another graph. And we are going to graph ln of x. ln of x is a special logarithm. Log, when you don't write anything, there's a base of 10. That's called a common log. ln is short for, I think it comes from French, logarithm naturel, which in English is a natural logarithm. Ooh. But they still have the L first and then the N. On your calculator, it is not an I. Some people still go, oh, what does this in function do? No, it's capital, it's like a little L, but it looks like a capital I. It's not in. It's ln for natural logarithm. A natural logarithm has a base of e. It really doesn't matter. You should be able to graph any log with any base. They all have the following characteristics. If my base is e, I still have x equals 0 as my vertical asymptote. If my base is e, I still have the point 1, 0. And since the base is e, this is the only point that's going to be different. Instead of, like with base of 4, we had 4, 1. With a base of e, we would have e, 1. Same shape. This is the graph of the natural logarithm. Now in grade 12, we use logs a lot because our brains like to work with tens. Okay, once you get into calculus, you almost never use logs anymore. Everything is natural logs with bases of e's.